Hey everybody, welcome back to another episode of Vectra AI podcast, where we in the Vectra product team talk about the stuff we hear, what we learn, what we're working on, and occasionally rant on topics we're passionate about. My name is Tiffany Nip, and I am a product marketing manager on the product team. Today, I'm joined by Fabien Guillot, our technical marketing engineer director. Today's topic is a threat briefing on Midnight Blizzard, where Fabien will explain who is Midnight Blizzard, what do they do, how they operate, and the best ways to defend against them. With that, I'll hand over to Fabien.
Thank you, Tiffany. Very glad to be here and be able to talk a bit more about Midnight Blizzards. So before we jump in, a couple of things about me. I'm Fabien Guillot. I've been at Vectra for about 4 years. I'm leading the technical marketing team. I've been working in cybersecurity for around 15 years. I love packets, blue teamers. I've been working several years for different value-added resellers before moving to different vendors and finally end up at Vectra. Feel free to reach out to me through LinkedIn or my email address if you have any question. So Midnight Blizzard, they are known under many different names. Could be PT29, Cozy Bear, Nobeliums, the Dukes, etc. They are basically the foreign intelligence services from Russia. They have been targeting mostly governments, technology, and research industry, supply chains. So they were the one behind the SolarWinds attack that was make a lot of noise a couple of years ago. And that was also based on identity as well. They are known to be highly sophisticated. They are very high OPSEC. They always evolve their attacker methods using kind of cutting-edge techniques. And they are focused heavily on identity-based attack. So this talk today will be mostly focused on the Microsoft recent breach. But the most last two main activities behind Midnight Blizzards was not only Microsoft breach that was actually detected on January 12th by Microsoft, looking at their Exchange Online logs. They were breached end of November, according to them. So kind of lead to a month and a half between the time they were breached and the time compromised and the time they actually detected that. They disclose a lot more information end of January that help us to understand better what different techniques that the attacker used and are used during that presentation as well. After that, Microsoft disclosed early March, that the attack was not completely done. They were able actually to successfully exfiltrate some data, including some source code, using the credentials or using information that they were able to find in the first attack targeting Microsoft 365. It's not an isolated case. Microsoft disclosed that other companies has been breached the same way. As far as I know, HPE was the only one to confirm and to step forward, disclosing that they were breached the same way last year, and they were able to successfully exfiltrate some email and some other data. There may be more on the list, but that kind of the only one that step forward. So one of the key points from the recent activity and what make this attack very interesting. First, there is no 0-day, there is no malware, there is no exploit involved in it. MFA is not enforced in the majority of the monthly active users. So Microsoft disclosed last year at Ignite that 62% of the monthly active users across all environments didn't have MFA turned on. So it's still a big target for those accounts. And finally, was no endpoint interaction as well. Everything was API-based, cloud to cloud, at least for that first part of the attack. In the information that was disclosed by Microsoft, there was a very interesting statement which said the attack was not the result of vulnerabilities in Microsoft product or services, right? The product was just used as it was designed. So there is no fix, no vulnerabilities, nothing that's to be fixed by Microsoft. And if we can draw the parallels with a network where we talk a lot about living of the land and using the different tools that are available on an administrator on any computers to perform the attack, you can draw the parallel here when you just use the product as it's designed, using the same tools as anyone else. So overall, here we have midnight blizzards, mostly targeting cloud identity, and from there being able to compromise a principal or an account, being able to pivot back to SaaS application, and in that case, Microsoft 365. Here it was using applications, Microsoft application, and we'll dig deeper into that before for the rest of the presentation. So let's dissect a bit more this specific attack against Microsoft. So we have actually two different tenants here. We have the test tenants that was initially breached, and that's the attackers used to actually move laterally to a different tenant. So you have that concept of like trusted boundary between two different tenants that we're going to explore and go a bit deeper here. According to Microsoft, the threat actor gets in using password spraying attack. So a type of brute force where using low and slow attack. In that case, according to Microsoft, using as well a residential proxy network to proxy the traffic as close as it can to the actual users. They were able to kind of enumerate users that are valid in a tenants and start doing a password spraying attack. Those are very difficult to detect because first, you don't have any logs when you enumerate valid user in an environment. And when you do password spraying, you make sure that you are low enough to not have any account locked. So default configuration of Entra ID, which disable or lock an account when multiple failed attempt has been made, is completely bypassed by just making sure that you don't reach that threshold. So they were able to, using, according to Microsoft, low number of passwords, they were able to find access or valid account in that test tenants that Microsoft was using. And this specific account looked like had some permissions on applications, Entra ID applications. So either this account was application administrator, cloud application administrator, maybe he was owner of that app. Either way, it was able to create a new secret for that app, and that app was published and consented to the Microsoft production tenants. So this is where you have the trust relationship between those two tenants that allow you to move laterally. So as the color here represents the two different tenants that are involved in this attack, and you can hear that we move for purple, which was the test tenants, and now move to the target tenants as the attacker used that new secret it generated to access the production tenant with the permission that this app has in that tenant. So before we move in, a couple of interesting things. So there is some suspicious sign-on detections or unusual travel detection as part of E5, as well as part of the Vectra portfolio of detection for Microsoft 365. And a valid question is like, can I have a suspicious sign-on event for an application authenticating itself in a tenant? So using a certificate or a secret for those non-interactive sign-on, can you have any of those detections firing? And good things to know is actually there is not even a single log that is generating when you do perform such event. So by default, if you don't enable any additional diagnostic settings for these applications, every non-interactive sign-in will not have any logs that you can use. So you're completely blind when you have this event when someone log in as an app in a tenant, you don't have a single event that you can see for that. It's one of the interesting findings here. So following that, we have the app that is elevating its privilege. And we will go back a bit, step back, and look a bit how those application actually works. In the world of intra-ID apps, there is a couple of important concepts. The first one is the app registrations. It's also known as on-out app. What it is actually a global representation of an app across all the different tenants. Associated to that, each time you actually create an app registrations, you automatically have an enterprise applications object principle. It's also called service principle. This object automatically created when you actually create an app registration is a local representation of that app in that tenant. An enterprise application can be either local or foreign. So this illustration on the right really help to understand that concept. On the tenant number 1, I have an app registrations created, and automatically I have an instance of that application, which is the enterprise application, the service principal, creating that tenant. So I have the global representation as well as a local representation of that app in that tenant. Now imagine you actually publish that app into a different tenant. The app registration, which is global, still reside in the tenant number 1. But now you have a new object, a service principal that is created in the tenant number 2, which is an instance of that app. And every app and every permissions that has been consented and granted to that app on the tenant number 1 will be accessible on the tenant number 2. So those are very important concepts. The second important concept is the different type of permission that you can provide to a service principal on an app. And there are 2 sets of permission in parallels. There is app roles, predefined roles, or there is API permissions. And in that case, they can be delegated. So a user has to authenticate to the app to access those permissions, or the permission can be application, the app itself, meaning the applications can use those permissions directly. So example of those API permissions, more often those Microsoft Graph API, for example, permission that you can provide to an app. The second important concept before we move on with the attack is how you assign new permissions to a principal. And a principal can be a user, a group, a service principal, or an enterprise application to another one. So the first step is to actually a principal assign permissions to another principal. And the second step that has to happen is that an administrator has to step in and manually consent those new permissions to that principal. So it's not you can auto assign new permission to yourself. You can assign them, but someone else has to approve them and consent that you can have those permissions. What happened in this attack against Microsoft is there is some very dangerous permissions, API permission that you can use within Microsoft Graph. So in that case, the applications that was published from the test tenant to the production tenants most likely has the app role assignment read write all Microsoft Graph API permissions, which is extremely dangerous because it allows you to bypass the consent process. So a service principal could just assign to another principal or to itself new permissions without having anyone to consent to it. So that's what makes that role extremely dangerous, and most likely what the application that was accessed has to be able to elevate its privilege. There is a couple of very useful resources from Andy or Spectre Ops regarding this attack that you can access or go to have a more a deep dive on that. So going back to our timeline, after we have these apps that the attacker was able to authenticate on the production tenant using that app, he was able to most likely use that high privilege role to elevate his permissions. So according to Microsoft, the threat actors create the new users. So potentially the server principal has to assign itself new permissions, like directory read write all or something similar, to be able to create the new users. Once the new user was created, maybe or maybe not, the privilege was elevated. It could have used the same techniques to assign new role from that first service principal to that new users to elevate its privilege to something higher. That's not disclosed by Microsoft if that happened, but it's the step that could have happened in the attack. According to Microsoft, after that, on the test tenants, the threat actor created a new malicious app, a new app, and this app was then consented on the production tenant. So now you have an app that is completely controlled by the threat actors that is different from the first one that was compromised. Following that, using the same technique, using the very high privilege app role management, the attacker was able to assign additional permissions to that new app that was consented and provide, in this case, Office 365 full access as app permissions to this app. From there, on the test tenant, the attacker can just generate secret for this new app and authenticate and access email on the production tenants using that app to access all the different emails. So that's what kind of the overall timeline look like of the attack. So how can you prevent that, and how can you actually detect that? And the first things to note is, like, E5, for example, has some coverage with Defender, but it's extremely focused on initial access. So if you are able to kind of bypass those suspicious sign-on or atypical travel or anything like that, as we replicate the entire attack, there is not a single detection coming from them. So kind of like you need to not only focus on initial access, but you need to focus as well on what's happened afterwards, after the initial access and you have been compromised. So at Vectra, we provide a wide range of detection and models to cover multiple phases of the attack, and we're gonna look at them each step of the way. Another thing to note before we move on is here we are dealing with two different tenants. So you can ask yourself the question is like, okay, are you monitoring your test tenants the same way you are monitoring your production tenants? So that's why we use those two different colors, where if you monitor both, this is all the detection that you can expect to have. If you monitor only one, you will have a subset of the detection, but at least what coverage you can expect in that case. So here, the brute force. So same as Microsoft, with the attack using a residential proxy network and being very careful with where the logging attempts are made, even Vectra suspicious sign-on detection would probably not have fire. But following that, the brute force attack or password spraying, it could have triggered the brute force detection from Vectra. We have much more granular detection that Microsoft provide. So in the case that actually doesn't fire from Microsoft, it could fire in our case, just the way we build this model in our product. Second thing that you can expect from Vectra as a detection is that as actually you create a new secret for an existing app, you will have redundant access detections that's fire. So that's a detection that in the test tenant will have fire when the threat actors create a new secret for an existing app. Following that, when the attacker log in as the app in a production tenant, and the app elevates its privilege before creating new users. Here you can expect a couple of detection in the production tenant. You can expect the privilege operation anomaly, because we learn kind of the patterns and what's normal and not normal. And if this service principal never grants additional role or new permissions, high privilege permissions to itself or anyone else, that will trigger this anomaly. Also, the fact that the service principal gets a new scope, a new permissions, that will trigger a detection called suspicious auth application, where we monitor high privilege permissions that are assigned to applications or service principal. So 2 detection you can expect there. As we replicate the attack, we take 2 scenarios where we sometimes elevate the privilege of the user, sometimes we didn't, as 2 ways that the attack can go. If the user was getting global administrator role, maybe he didn't, but had fire actually 3 different detection in our portfolio when that happened. It triggered again the privilege operation anomaly, because maybe the service principal has never seen assigning these type of permissions to anyone before. That trigger the admin account creations as well as redundant access creations. So 3 different models that will fire in that case. Finally, again, when there is a next time there is a privilege escalations using this very dangerous permission where you can assign new role without any consent, you will have 2 more detections, which is privilege operation anomaly, again, as well as suspicious auth applications, because Office 365 full access as app is considered as a high privilege permissions. And finally, again, where the threat actors generate new keys, new secret for this new app he created, that will have fire in the test and as these redundant access detections. So you can see here, as we replicate the attack, the broad coverage that Vectra provide, not only covering the initial access part of the attack, but also what happened within the environment and how someone can move inside or between environments and get to its target. Yeah, so to conclude here, so you need a couple of different things, right? When it comes to detect threat with Microsoft 365 and Entra ID, those are very complex environments. And having Microsoft bridge using Entra ID and Microsoft 365 by a threat nation state actors, just so like anyone can be impacted. Those environments are extremely complex, extremely difficult to protect completely. There is always something that can be misconfigured or some of the things that can lead to be breached. So the first things to get is to get the right coverage, right? Do you get the right visibility? Are you monitoring your Microsoft 365 Entra ID environment? You have the right set of detection to detect this kind of attack as early as possible. And again, no matter if you monitor all your environment, all your tenants, because you can imagine probably the company like Microsoft have many, many different tenants that interact with each other and make things extremely complex. Even if you monitor some of them, do you have the coverage to protect your asset? Finally, the clarity, using AI for high fidelity detections, as well as using AI for prioritizing. So as we have a principal or service principal in that case, starting to do multiple behavior that looks suspectful, how you able to prioritize to get, this something you need to look at right away. So clarity is a big component of that. And finally, control. When you see a threat, when you prioritize a threat or something that is highly suspicious, what can you do? And things like the native response that we build in our platforms to automatically lock down or disable an account, or maybe through something like MFA reprompt by revoking all the sessions. That things that you can implement either doing manually or automatically to respond to such attack. So in that scenario as a test account, I mean, that account compromised in the test account, as we see detection on that, we could have take, response as early as that to disable this account, revoke the different sessions that are open, and block the attack. Yeah, that's all. That's all I have.
Yeah, thank you, Fabian. Super great session, very detailed and insightful. I have one quick question. As you mentioned, Midnight Blizzard persisted in Microsoft environment for 1.5 months. With the vector detection that you highlighted in the slide just now, how fast would you say can Vectra AI stop a similar attack?
That's a very good question. One of the things to note is when we talk about prevention that we didn't really talk about during this presentation is like one of the first things you could do in an environment or your environment, if you have to do something now, is to audit all your applications and look at the different permissions that were assigned to those applications. And you have a list of all those very high, elevated permissions that are very dangerous, and you make sure that any application that have those permissions, why do they have those permissions? Do they need those permissions? Do I need to take any action to remove those permissions? So auditing is the first step that will prevent that to happen. But in a very complex environment with all those different applications, all that complexity, it's very difficult to keep track of that. So such configurations that was in place like that could happen. In the world of Vectra, when actually you published and consent to an app coming from a different tenant. So there is a new service principal that is created within your tenant and has high elevated permissions, and you have to consent them. Someone can have done it, right? An administrator can just like, okay, he knows the person publishing this application. This is a test tenant. I approve that. In Vectra with our product right away, when this application is published and consented, that will have fire detection right there.
Yeah.
So even if it was not audited successfully, or maybe some administrator were doing some testing, at least the SOC, will have been notified that, well, there is something where this app has been published, consented in our production tenants with those very high level permissions, and right away it will have triggered a detection in our product. So that this is as early as it could have been detected before even the attack happened.
Yeah.
Then is scenario where the SOC analysts say, okay, I check with the administrator and that's okay. Because we don't know how long this configuration has been there.
Yeah.
But at least in late November, when the attack happened, very early on, you could have also have sign of compromise where these service principals start acting weirdly, starting elevating privilege, starting to create new users, starting to assign new role, etc.
Yeah, great. Thank you so much again. Very, very insightful. And with that, thanks everyone for joining us in this session, and we will hope to see you in the next one. Thank you.